question 43 from the GATE 2018 EC paper, where we are given that the two transistors M1 and M2, which are NMOS transistors, have the same threshold voltage, but that M2 has a W/L ratio twice that of M1. And we are also given the drain current equations for both transistors for the two regions of operation. If the input voltage is 2 volt, what is the voltage Vx? Underneath the question, you will find the title of the NPTEL course or video most relevant to this topic.
So let us proceed with solving this problem. We are given that the gate voltage is 2 volt and we need to find what the value of Vx is given two NMOS transistors connected to a supply of 3.3 volt. So to do that, we will first find out what the region of each transistor is, get the corresponding drain to source current equation for the two NMOSs, and then equate the two currents as a KCL on the Vx node. So the first step is an analysis for M2. In M2, we are given that the VGS is greater than 1 volt, right? And since Vt is equal to 1 volt, the transistor M2 is on, so M2 will be in turn on. So we just have to figure out which one of the two current equations apply based on the value of or the relationship between VDS and VGS minus VT. So VD is 3.3, VG is 2 volt, VG minus VT is 1 volt, right? VG minus VT is less than VD, which is the same thing as VGS minus VT is less than VDS, right? And so we get that this transistor is in the saturation region. That is, the second current equation applies. And for M1, we are again going to look at that we again have VGS is equal to 2 volts, so it's in the turn on region, right, because it's greater than VT of 1 volt. So VD is less than 1 volt, right? VG is equal to 2 volt, VG minus VT is 1 volt, so VG minus VT is greater than VD. Thus this transistor must be in the, that is M1 must be in the linear region, right? And how we get that VD is less than 1 volt is through this, right? It comes from the fact that the source of M1 is the source of M2 is the drain of M1. So now we have the two current equations, one linear and one saturation. M1 is in linear and M2 is in saturation, and we simply reduce the equations to being in terms of the variable Vx, right, by substituting. And of course we have to remember that M2 has 2 W/L whereas M1 has W/L, because the W/L ratio value for M2 is twice that of M1. And then finally we have to equate the two currents, that is IDS M1 is equal to, that is the current coming in to the Vx node, is equal to the current leaving the Vx node, that is IDS M2, right? So equating the two currents and then reducing, we get this quadratic, right? And then we get the roots of the quadratic, which is the values, potential values for Vx, and we can discard 1 plus 1 over root 3 because we need a value of Vx less than 1. So Vx is 1 minus 1 over root 3, which is 0.4226 volts. Thus the correct answer is 0.4226 volts. Rounding off to 2 decimal places, that's 0.42.